Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over pOH scale and other P scales. So let's get into this. In my previous video I talked about pH scale and where that comes from, and so let's remind ourselves about that. So remember, the pH of something is equal to the negative log of the H plus concentration. So therefore, if you take the negative log of, say, for example, if you're neutral water, if you're in pure water and that's neutral, you're going to have 1.0 times 10 to the negative 7 H plus concentration. You plug that in and you get a pH of 7. So here you have the pH of 7. If you and that's going to be associated with an H plus concentration of 10 to the negative 7. What if your H plus concentration is 10 to the negative 3? You take the negative log of 10 to the negative 3 and you get a pH of 3. So one thing I want to point out is that, as you can see here, if I increase by 1 on the pH scale, so if I increase from a pH of 8 to a pH of 9, that, of course, is an increase of 1. But notice that what happens with the H plus concentration here, so my H plus concentration is going from 10 to the negative 8 to 10 to the negative 9. And that is a decrease in the concentration of H3O plus by a factor of 10. So anytime you increase or decrease by 1 on the pH scale, you're actually increasing or decreasing by a factor of 10 in your concentration of your H plus. So be aware of that. And they're opposites of each other. So an increase in pH by a factor of 1 is a decrease in the concentration of H plus by a factor of 10. So that's something to keep in mind. So now that we've kind of reviewed the pH scale, let's talk about the other scales like the pOH scale and other P scales. So the pOH, as you can remember, is pretty much the same as pH, except instead of the H plus concentration, you're taking the negative log of the OH minus concentration. So pOH is equal to the negative log of the OH minus concentration. So if you remember from before, the H plus concentration and the OH minus concentration are inversely related to each other, and they're related to the Kw. So remember this. So your H plus concentration multiplied by the OH minus concentration is equal to 1.0 times 10 to the negative 14, which is your dissociation constant for water. So this, again, this is at 25 degrees Celsius. So if this stays the same, right, if our temperature stays the same, then this is constant. This is always going to be the case. So remember, increasing the H plus concentration will decrease the OH minus concentration by the same factor. So if you increase the H plus concentration by a factor of 100, then you decrease the OH minus concentration by a factor of 100. So if we keep that in mind, the pOH scale is going to be related to the OH minus concentration. So we plug in our OH minus concentration, take the negative log of that, and we get what is called the pOH. So, and then the pOH is going to be the inverse of the pH scale. So that's what I have down here. So excuse, it's kind of on it's on a decline here. It's not that straight, but my apologies. So bear with me. So you'll notice at the acidic end, we have pH is 0. So remember, if you are increasing the amount of H plus concentration, your pH is decreasing. But remember, if you're increasing the H plus concentration, what's happening to the OH minus concentration? It is decreasing. So as H plus increases, OH minus is decreasing. So notice that the pOH would be 14 when the H plus is 10 to the 0. And if H plus is negative 5, 10 to the negative 5, then the OH minus is going to be 10 to the negative 9, which gives a pOH of 9. So that the scales, the pOH scale is the inverse of the pH scale. And so what's acidic on this side, so for pH, 0 is acidic, or 1, 2, 3, those are acidic pHs. But for pOH, acidic is 14, 13, and 12. So they're inverses of each other. Okay, so the other thing I want to point out here is notice that we have pOH is equal to negative log of the OH concentration. So I want to show you how we get another relationship from these relationships here. So we know that the H plus concentration and the OH minus concentration is equal to Kw, which is 1.0 times 10 to the negative 14. So let's take the log of both sides. If we take the log of this, and then we take the log of the 1.0 times 10 to the negative 14, which is the same as taking the log of the Kw. So according to the law of logs, if we take the log of two things that are multiplied, that's the same as separating them and adding them, the two logs. So I can take the log of H plus concentration and add that to the log of OH minus concentration. So that's a law of logs. And so that's going to be equal to negative 14 because I'm taking the log of this number, which is 14, negative 14, so I get negative 14. Notice that I have two sig figs here and I have two decimal places. Now that's going to be equal to the log of Kw. Now let's take the negative of both sides. So if I take the negative of this side, I get negative log of H plus and then minus or negative log or plus the negative log of OH minus concentration. And that's equal, if I take the negative of a negative, that gives me a positive, and that's going to be equal to the negative log of pH. But as we have seen, the negative log is the negative log of something is the P of that thing as well. So if I have the negative log of H plus, we said that was the pH. So we have pH. And then the negative log of OH minus, we just saw, is the pOH. So that's plus pOH. And so pH plus pOH is going to be equal to 14, which is the pKw. So negative log of Kw is the pKw. And so here is a new relationship that we can use. So we now know that the pH plus the pOH is equal to 14, which is the pKw. And so we know that the pOH is equal to the negative log of the OH minus concentration. We know that pH is equal to the negative log of the H plus concentration. And we know that H plus concentration multiplied by the OH minus concentration is equal to 1.0 times 10 to the negative 14, which is the Kw at 25 degrees. So we have four relationships here that we can use, four equations that we can use to solve problems involving pH and pOH and Kw and pKw and all of that. Okay, so one final thing I want to point out is you'll notice that P ends up being an operator that means the negative log of something. So pH is the negative log of H plus concentration. pOH is the negative log of OH minus concentration. So if you have something that you take the P of, P say X, PX, that's going to be the negative log of whatever X is. So that is, P ends up being this mathematical operator that means taking the negative log of that thing. Okay, so what about other P scales? So we've already seen the pKw, which is the negative log of the dissociation constant of water. What about pKa and pKb? These are other P scales. So in a previous video, we talked about Ka values. So remember that the Ka value is the dissociation or ionization constant of an acid, right? That's what the A means. it's for the acid. So this is the equilibrium constant of an acid in water, right? So remember that the Ka value of a substance, of an acid, is a measure of the strength of that acid. If the Ka value is large, then that means it's a strong acid, right? If it's a small Ka value, if that Ka value is really small, then it's a weak acid. It means it doesn't dissociate or ionize in water very easily, right? So most of it is going to stay in the HA form, right? So if you take the negative log of your Ka value, you get what is called the pKa value, right? So the pKa value then is going to also be a measure or indicator of the acidity of something. So for example, let's say that the Ka value, right, the Ka value of some acid is 1.0 times 10 to the negative 2. So that's a relatively large Ka value, right? So if we take the pK of that, right, to find the pKa, we take the negative log of the Ka. So we take the negative log of this, and we get we get a positive 2. So the Ka value would be 2 because the pKa value would be 2 because we're taking the negative log of 1.0 times 10 to the negative 2. So that would give us our pKa value, right? Same thing with what is called pKb. I haven't talked about pKb or KB in any videos yet, but you can imagine that B stands for base. So we could talk about the dissociation constant of a base in water, and that would be the equilibrium constant of a base reacting with water, and how easily it would ionize or dissociate in water. And so if we take the negative log of that, we would get what is called the pKb. And that would be also a measure of the basicity of the base. And so we'll talk more about that in another video, but these are other scales, these are other P scales that you can use that are useful. So I hope this is helpful. If you enjoyed this video, if you found this really insightful and helpful in understanding, please like the video, hit that like button right there, smash it. Subscribe to my channel. Make sure that you hit that notification bell so you can get notified by other videos I put out. Put a comment down in the comment section. Let me know what you think, and if you have any other questions you want me to answer. Thanks for joining me. Have a great day.